Arrays in C programming. Welcome to this session on arrays in C programming, an essential topic for anyone learning low-level development. I'm Behnam Jafari from PicoBit Tech, and in this video we'll walk through arrays step by step, starting from the basics all the way to more advanced concepts. Here's what we'll cover in this session on arrays in C. First, we'll start with what an array is and why we use arrays in programming. What is an array and why do we use arrays? An array is simply a collection of multiple data elements of the same type stored in continuous memory locations. You can think of it as a row of boxes arranged back to back. Each box holds one value, like temperatures, sensor readings, or test scores. This continuous layout makes arrays fast and efficient. Why do we use arrays? We use arrays because they let us store many values without creating new variables for each one. We use arrays because they let us store many values without creating new variable for each one. They give us fast access to data and are essential in many real-world scenarios, like storing sensor data, handling serial communication buffers, creating matrix, and representing strings. Declaring an array, initializing an array in accessing element. To declare an array, we specify the type, the name, the size. Here, int nums index 5 create an array that can hold 5 integers. Remember, the size must be a fixed value known at compile time. Initializing an array. We can initialize an array in two ways. The first method is to define the size and list all values like int. The second method is to skip the size and let the compiler determine it automatically. Accessing elements. Each element of an array is accessed using its index. Nums index 0 gives us the first element, and nums index 1 gives the second one. And remember, this is very important, array indexing in C always starts from 0. Array indexing in C always starts from 0. Looping through an array. The most common way to process an array is by using a loop, usually a for loop. In this method, we start the index from 0 and increase it up to 1 less than the size of an array, because the last valid index is always size minus 1. This is very important. Common mistakes. There are a few common mistakes when working with arrays. The first one is accessing an index that is out of the range. Another mistake is using an uninitialized array, and the third is miscalculating the array's size. These errors can lead to bugs or crashes, so always be careful. Declaring and initializing a 2D array. A two-dimensional array is simply an array of arrays. Here, we have a matrix with 2 rows and 3 columns. 2D arrays are extremely useful in applications like image processing and data tables, sensor grids, FFT operations, and digital filters. We are going to look at how to declare and initialize a two-dimensional array in the C programming language. Here, we're creating an array named mate with 3 rows and 5 columns, which means it contains a total of 15 elements. The code looks like this. We start by using the data type int, so all elements in this array are integers. Their brackets 3, 5 indicate that the array has 3 rows and 5 columns. Inside the curly braces, we perform the initialization. Inside the curly braces, we perform the initialization. Each set of braces represents one row of array. The first row contains the value 10 through 50. The second row contains 15 through 55. And the third row is initialized with 12 through 52. By initializing the array at the moment of declaration, we avoid assigning each element manually. This makes our code cleaner, more readable, and more efficient. Accessing 2D elements and looping through a two-dimensional array. To access an element in a 2D array, we use two indices, the row and the column. For example, mate 0, 2 means row 1, column 3, which give us the value 30. Looping through a 2D array. To work with all elements of a 2D array, we use nested loops. The other loop goes through the rows and the inner loop goes through the columns. This prints every element in the matrix. Character arrays or strings in C. In C, strings are actually stored as arrays of characters. For example, char name Pico creates strings behind the scenes. Each character is placed in a separate array elements, and the string ends with a special null character or \0. A string in C is a character array. A string in C is a character array. Behind the scenes, when we create a character array in C, we're actually building a sequence of characters stored one after another in memory. For example, when we write a definition with 5 elements and assign the characters P, I, C, O, and the special terminator \0 or null character, the compiler stores each character in a separate memory location and automatically treats the array as a proper C style string. The final element, the null character, marks the end of the string, so functions like printf or strlen know where the text stops. This simple structure is what allows C to handle strings efficiently at a very low level. Real applications in embedded systems. In practical C programming, arrays play a critical role in organizing and processing data efficiently. We use them to store large sets of values, such as capturing 100 or 1,000 ADC samples during signal processing, or handling communication data through UART, RX, and TX buffers. Arrays also make it easy to manage RGB LED frame data, where each LED's color values need to be stored and updated quickly. In filtering application, moving average filters rely on arrays to keep track of recent samples for smoothing signals, and for performance critical tasks, we often use lookup tables, allowing the program to access pre-computed values instantly instead of recalculating them. These examples show how arrays form the backbone of many fast and reliable embedded system operations in C. Summary. In summary, arrays are a fundamental part of C programming and are especially important in low-level and embedded systems. They form the building blocks of strings, buffers, matrix, and many algorithms. Without arrays, most real-world programs simply won't be possible. In our next video, we will explore strings in C programming. If you want more videos on microcontroller programming, don't forget to check out our playlist. The link is right at the end of this video. The link is right at the end of this video. And to support us and never miss a video, hit that subscribe button. Thank you so much.